prefer one, some students prefer the other. I present them both and pick the one you like. I would recommend pick one of them, learn it, understand it, and go with it. If you can do it both, great, but the biggest trouble students have is they start mixing and matching the two techniques. So, questions on this before I show you how to come up, the second way of coming up with equations? All right, so we have our answers over there. We're coming up with a new set of equations, so we don't need that. Yeah, let's take a break. Let's take a 5-minute break, stretch legs before we do what's known as mesh analysis. For one current per loop instead of that. Get that wrong. And I've done these before where we're doing what you're suggesting. So you end up with a set of equations here with, I'll just make up new numbers here.
Yeah.
So 5a minus 3d plus 4c equals 7. 2a minus 1d plus c equals 8. And 6a minus 6b plus 2c equals 3. So the matrix you would set up would be, that is not any better. So 5, negative 3, 4, 2, negative 1, 1, 6, negative 6, 2, times A, B, C equals 7, 8, 3. So that's basically the matrix you're setting up. So if that's, let's call that M times U for unknowns is equal to constants. If you multiply times the inverse of matrix M1, you'd get the identity matrix, and then so your unknowns would be equal to the
inverse of M1.
The inverse of M times C. And then so perfectly legitimate to do it that way. Just I find it a little bit more cumbersome than the other techniques.
Yeah, and I was trying to like do a little Googling on like why you use Cramer's rule versus that, or why you use Gaussian elimination over Cramer's rule, and it seems like for 3x3 matrices where you're just trying to find a solution, Cramer's rule is great, but beyond that, it's easier in some ways to use the Gaussian elimination.
Yeah, I would assume part of it is if you're writing a program to solve a generic set,
Yeah.
that it depends upon whether the inverse matrix function has been defined already or determinants has been defined. It's possible both have been, so. But I'm trying to think, I was dealing with 100 by 100 matrices in my dissertation. And I think I was primarily dealing with inverse matrices instead of Cramer's rule, because it's what I had.
Mm-hmm.
Overflowed the buffer a few times. Tried to save everything so to save time in the processing. Yeah, it didn't like that. I give you any more insight?
Yeah, that's good.
Okay. Any other questions right now? All right, so mesh analysis, we're getting rid of these. Now recognizing the first technique we did, those currents went from junction to junction. The second technique, we're ignoring the junctions and we're just looking at loops. And I got 3 loops. I got left, right, and the whole thing. I typically do left and right just because. So what I'm going to do here is, since I'm starting from scratch there, I'm going to take the left loop and I'm going to either go clockwise or counterclockwise, and it really does not matter. I'll just go clockwise, and I'm going to call this I1. Or actually, since I don't feel like writing much, I'm going to call this D, or that's the current, left current. So I left loop is D. And over here, I'm going to go clockwise or counterclockwise. It doesn't matter. I'm just going to pick clockwise again. And I'm going to call this E. So I right loop. All right. I have 2 unknowns here. I'm going to do my loop rules just like I did before. The tricky thing happens in the middle. So let's deal with that. So I'm going to start on the left-hand side. I'm going to start in the exact same place I did before. So I got my 5 minus, I'm going in the direction of current D here across my 6 ohm resistor, so minus 6D. My 7 ohm resistor, I'm going with D, but I'm going against E. So minus 7D plus 6, not 6, plus 7E, plus 10 minus 1D equals 0. The tricky thing is the overlap between the 2 different current loops that we have. So, one equation, 2 unknowns. We need another equation. Question? Devon, I saw you working through that. Are you good, or you off a little bit?
I'm good. You just, I guess, just at 7, you do it 2 times if it's, I guess.
Because I got 2 different current labels going across that middle.
Okay.
And you only do that for your resistors, even though the battery is in the D loop and the E loop?
Yeah, because the voltage, the change in potential across the battery is set by the battery itself,
Okay.
regardless of what the current ends up being. All right, so now, the second loop, I can either do the right side or the whole thing. Let's do the right side. I'm going to start here at the 4, and then I'm going to go around. I'm going opposite the direction of my current E, and that's okay. Just have to take that into account. So I got 4. I'm going across the 2 ohm resistor against E, so plus 2E. Now I'm going down across 7, so that is, well, minus 7D plus 7E, plus 10 equals 0. This technique and the other one, notice that we have taken into account every resistor has shown up into at least one equation. Two equations, 2 unknowns. It's a simpler math problem at this point. Again, the tricky part is making sure you get D and E taken care of in the middle.
Even though you're going in the direction from the right, would it matter that you use the 7D first, or?
Oh, it says
Yeah.
doing that instead of that?
Yeah.
No, it does not matter which one I do
Okay.
first. I just have it of left to right.
So is there a reason we went counterclockwise even though our current was clockwise?
The reason I did it is that I like starting in front of a battery and then making the first number positive. That's just my own idiosyncrasy, because I wanted that to be a positive number.
So if you had gone the other way, it would flip all the signs in that second.
If I'd gone the other way, all the signs would have changed.
Okay.
And if I multiplied by -1, then it would have ended up with this.
And I guess it doesn't matter where you start in the circle, it should end up with the same equation, right?
Absolutely. And if you did figure eights, I mean, if I did this and then came along here and did something like that, that would be the equivalent of just doing the whole loop. All right, so now, questions before we simplify it? So the first one, I've got like 10 and with 5, so I've got 15. And then I got my D, D, and D, so it's minus 14D plus 7E equals 0. The second equation, I've got 14. And then I got just 1D, negative 7D plus 9E equals 0. And now it comes down to how do you want to solve it? We can use Kramer's rule, just it'll be a 2 by 2 determinant, which is simpler. Or I can multiply that bottom equation by negative 2 and then add the two equations and D would disappear. Let's do it that way this time.
That sounds a lot easier.
So if I multiply this whole thing by 2, so that first equation stays as is, so minus 14D plus 7E equals 0, and the second one becomes 28. So multiply times negative 2, negative 28 plus 14D minus 18E equals 0. I could have multiplied by positive 2 and subtracted the two equations, but mentally, I prefer to add, so again, it's my thing. So negative 13 minus 11E equals 0. Oh, okay. And so E ends up being negative 11/13.
Well, 13 11s.
Thank you.
That's the, yeah, you're right.
And then, oh, let's just go convoluted here. Because that first equation there, I got negative 14D plus 7E equals negative 15. And we'll do that formula over there. Negative 7D plus 9E equals negative 14. And so D would be, so I got negative 14, negative 7, 7 and 9. Use my first one, so up here I have negative 15, negative 14, 7 and 9. Negative 105 minus negative 98. And in the denominator, so negative 126 minus negative 49. Seven. Something went off.
I think that's flipped.
Because I would expect to get 0.48. So,
-7 would have to be on the bottom, and you'd end up with something
This
on,
one's right.
something on the top would be along the lines of 3.336, or 3.3636 continuing. To get to 0.48.
sorry, you were,
I just took the E and plugged it back in.
To the 7, to the,
To
negative
the-
14D plus 7.
Yeah.
You got like 4.48, right?
Yeah.
Okay.
all right. Okay, so obviously that technique worked better this time, but where on earth did I go wrong? Oh, wait. No?
But -7 would have to be on the bottom, of the denominator, if you have a -7. The numerator would be some fraction.
Yeah, but in terms of setting up Kramer's rule, I have negative, we're good with this because it gave us the right value for E, because E, we got a negative value, but that just means it's going the opposite direction across the 2 ohm, which is what we had last time.
It should be -135.
135, so negative 37. And this would be Say it again? negative 77?
Yep.
All right, those numbers are looking good. All right,
Those are familiar.
which is 0.4. Now, when you get this problem on the last problem of the test, and you're faced with this, what the question, the way that I want you to display the answer is, so for the resistor, I got 1 ohm, 2 ohm, 4, 1, 2, 6, and 7, 6 ohm, and 7 ohm. I typically do them in numeric order. Then I want to know the current and the direction. So across my 1 ohm, D is going to the left across the 1 ohm, and only D is going across the 1 ohm. D, I got 0.48, so this would be 0.48 amperes left. And I'm fine with the arrow. If you want to write out the word left, go for it. The 2 ohm is at the top. I have E going to the right, but I have a negative value for E somewhere down there. This right here. And let's go for the decimal. That was 1.18 repeating. 1.8 repeating. So the 2 ohm, I can write it 2 different ways. I can just stick with the numbers that I have there and write negative 1.18 repeating amperes going to the right, which is the way I had defined E is going to the right across the 2 ohm resistor, and that's perfectly fine. Or 1.18 repeating amperes going left. It's the same answer.
Okay. Took the negative off.
Yeah, the negative just, and then flip the direction. What I have seen some students do is they get the negative, and then they go up there, and then they change the direction up there, and leave the negative in their answer.
It messes up the whole.
Yeah, you change neither, or you change both, but don't change one and not the other.
So it doesn't matter that you went counterclockwise when you made the equation.
Right.
Why doesn't that matter at this point? Why wouldn't it be the opposite?
Because whichever direction I take to do, I assume you're talking about the voltage loop.
Yes.
Whichever direction you take, you're gonna take the sign into account. The fact, I took into account the fact that E was going to the right here, because when I did the loop, I'm going against current, basically going up the hill. I put a plus here. So, it's, all the little things are taken into account. That's why it doesn't matter. I know that's a very vague and general question, but we're getting the same answer as we had before. And the nice thing about that is, if it doesn't matter, as long as you keep track of the right pluses and minuses, depending on which way you're doing your voltage, based upon how you define the current, it all works out. You got the flexibility and freedom to do it however you feel like at that moment.
So
6 ohm would be 0.48 amperes. Going to the right. And 7's the tricky one. Because for the 7, I've got 0.48 going down, and I have negative 1.18 repeating going up.
add the two?
Pardon?
Do you add the two in the difference?
As long as you, well, I got a negative in an upward direction, so however you wanna deal with it, I personally would flip the direction and make this 1.18, and now I have them in the same direction, and just add them.
Oh, okay.
If this had been positive and that had been negative, or sorry, if this is positive up and that's positive down, then it's the difference between the two.
Okay.
They're not vectors, but in essence, you're adding them like parallel or anti-parallel vectors.
Okay.
And the direction is essentially just so you know we're getting like the sign right, I guess, like you wanna know the way the current's flowing.
Yeah. Right. Again, ultimately, anything you put into a circuit when you get to the design phase is you're trying to control current to flow in a particular way at a particular magnitude.
Right. Okay.
And so the last one is down of 1.66.
That is a non-test question.
And then, the last thing I usually ask you to do on this problem is I ask, what is the potential drop across, and then I pick one of the resistors. What is the potential drop, or what is the change in potential across the 2 ohm resistor? Now, I have students who get all this, they get all of this right, and then they mess up on this last step. You know, on a 15-point problem, they lost a half a point. It's not a huge impact, but it's still that frustration of being so close to getting the perfect answer. So the change in potential across the 2 ohm resistor. There is a direction. I know that my current, as I had up earlier, is 1.18 amperes going to the left. If I'm going with the current, my potential drops. So I use Ohm's law, multiply 1.18 times 2 to get my voltage. So the voltage here is 2.36 volts. 2.36 volts. If I'm going with the current, I'm dropping. If I'm going against the current, I'm gaining. So if I want to make this positive, I have to go against the current.